Good to be here. Thanks for coming along. And thanks for coming to a talk that you didn't hear about until this morning. So I'm excited to be here. And I want to try and spend the next 50 minutes or so. The first talk I have is not going to take 50 minutes. So I actually have two. I'm going to see if we can squeeze them in. So the first one I want to go through is general authorization flows. Some of the ones that you've probably heard of and some of the ones you might not have, how they work, why you might choose them over something else, in which kind of situations they are suitable. And then if we have time, we'll certainly have time to start the second process. I want to have a look at WebAuthn and what the flow of that is. I did put my watch onto Do Not Disturb, and yet somebody has decided to call me at this very moment, so excuse me while I try not to be distracted by my left arm vibrating. My name is Dechrai. As you've heard, I work for Auth0 as a developer advocate. I live in Melbourne. I'm very happy to be in New Zealand for the first time this year, and hopefully it won't be the last. In fact, it won't. I'm coming back next month for a bit of snowboarding. If you like snowboarding, come chat to me at the booth about that. Also, I want to do a quick call out. You're probably all aware of the fact that there's a Lego build going on in one of the rooms. Please go and help John. I think he might be the only person building it, and we need more people building that Lego. So go and have fun building the Millennium Falcon. That's all I'll say about that. Unless you ask about me more, in which case I can talk for hours on end about it. All the flows. So not necessarily actually all the flows, a lot of the flows. Let's dive in. There's one in there as well which is deprecated, but we'll go into why I'm describing it to you and why we don't use it anymore. But let's start with what is possibly the most common one why is my clicker not working? The most common one that you've probably come across, which is called code flow. Is anybody familiar with these flows? Like if I said to you Authcode flow, device flow, machine-to-machine flow, got probably about 5%. That's good. You're in the right place to learn about this. And for those of you who've heard about them already, hopefully there's some information in here that's going to essentially help you understand why they work and how they protect you. And understanding how the flows work is going to allow you to potentially not also break them, because as much as tools like Auth0 can help take away a lot of the complexity, it's still possible to break things if you circumvent some of the underlying fundamentals of what's going on. So, Authcode flow. I'm going to have to stand near my laptop because I think the problem is my clicker's battery is running out. It works over this side, so hello over there. I like to greet both sides of the room. So, Authcode flow. The first step is you have your web application up here on the left, and you have some kind of system that you're trying to log into, your back end on the top right. And you've got an identity provider at the bottom. This could be Auth0, it could be Okta, it could be Ping, it could be Cognito. The only thing I ask you to do is not to roll your own. That's probably one of the biggest competitors in the ID space, is people who roll their own. And in the same way as you shouldn't write your own crypto, it's probably a good idea not to write your own identity, because there are so many things that can go wrong. So the first step is you have a login button on your web application, or rather you have a link to a resource in your web application, and the request goes to your backend, and your backend says, you know what, I've got no idea who you are. I don't know that you're supposed to have access to this information, so I'm going to need you to log in. So the web application is going to send, I'm going to use my keyboard because the clicker is just not happy today. Apparently it is, and it's jumped up ahead. Perfect. So the first thing it's going to do is this dotted line here represents a redirect. So it's sending a response back to your browser, or to your user's browser. And it includes at least two, but there's a couple of other bits of information. But it includes two key bits of information. The first one is the client ID, and we'll get to that in a second. And the other one is a set of scopes. And this is basically telling the identity provider that you're about to be redirected to what kind of information your application needs. And by default, one of those scopes is going to be OpenID, because we want an OpenID Connect login process. And just quickly, OpenID is basically a thin layer that sits on top of OAuth, OAuth being the authorization framework that allows you to do things like, for example, I authorize LinkedIn to talk to Google to get my contacts. So get my contacts would be a scope in that sense. OpenID is a layer above, which allows you to say, I permit this system to talk to that system to get my identity. And if you've ever seen a login with Google button or a login with Twitter button, that's essentially what's happening there, is you're authorizing a system to talk to Twitter to get your identity. That's what we call a social login. So the scopes come back, and also the client ID. The client ID is basically a key that tells Auth0, or the identity provider of your choice, where the user is about to be logged into. Because the next step is your browser then honoring that redirect request and taking the user to your identity provider's login page. And the login provider, or the identity provider, is then going to take that key and say, OK, Ben's trying to log into this website over here. I can tell that because of the client ID. So it's going to be able to generate a login form for you, which is hosted by the identity provider. There's a little loop back here. This is like an optional. If you've already logged in once to this identity provider, that identity provider is going to remember you. So you've got almost like a single sign-on experience here. But if you haven't logged in, you're going to be presented with that login form, and you're going to authorize yourself to the identity provider. So here you can see that your credentials, your username and password, or whatever your authorization credentials are, only go to the identity provider, not to your back-end application. So at this point, the identity provider is going to say, okay, well, Ben has just logged in, and we're going to generate some kind of code. It's cryptographically randomly generated, but it has no context. So just looking at that code is not going to tell you anything about me. But the identity provider is going to remember this code was just generated because Ben logged in. The identity provider remembers that, sends that back as another redirect to your browser, which your browser is then going to send back to your web application in the back end. So the web application got a request for a resource, said, I need you to log in, did a redirect, and in response, it got an auth code. With that auth code, the identity provider is now going to be able to make a direct server-to-server communication request over HTTPS, so it's secure end-to-end, extremely unlikely to be man-in-the-middle attack. And it's going to pass in the client ID again to say, hey, this is where the person's logging into, so there's that frame of reference. It's also going to pass in the second one there, which is the secret key, and this is basically almost like an API key. This is your application saying to Auth0, hey, I'm authorized to make this request because I've got this secret key. And it's also going to provide in that auth code that got sent back to it via a redirect. So your application now in the back end, it has its secret, its API key, and it knows what its client ID is, and has received this auth code, and it's basically saying to Auth0, here's the auth code I just received. Give me some information about the user who just logged in. And Auth0 is going to take that code, and because it remembered, hey, this code is because Ben just logged in, it goes, oh yeah, that's because Ben just logged in. The auth code matches, the client ID matches, and the secret key means that I'm allowed to, or Auth0 is allowed to respond back to your back-end application with the response. And in that response, it sends 2 or 3 tokens back. Because this is a post request, it gets returned as the payload of the response, which is a lot more secure. And we'll come to a potential issue that gets solved by this when we look at single-page apps in a second. But essentially, this is the loop. You can see here that even though I, as a user, have tried to get a resource from your web server, and I've been redirected to an identity provider, and there's all this stuff passing via my browser, and as we all know, browsers are probably the most insecure system on the entire internet. We've got no idea what's happening in people's browsers, so we don't want to be sending sensitive information via the browser. But using that auth code and that loop back at the end there where your application does a server-to-server request, we're assured of the fact that the tokens that come back are for the person who just logged in and can't have been tampered with through any of the requests that went via the browser. Does that make sense? It's a complicated one, and the rest of them get easier once you understand this one. But this is probably the default one that most of us will use when we use a standard front-end, back-end type web application, whether that's Next.js or .NET or Python or whatever your language of choice is there. So those tokens that come back then allow your application to know that the user is authenticated. It can check the identity of the person from the ID token, which is the first one there, and return the resource. The other thing it can do is take that second one, which is the access token, and it can talk to a first or third-party API and use that access token. This is where the authorization part of it comes in and says, hey, I've got this token that was generated when Ben logged in. I want to get information on behalf of Ben. So we've got that authorization thing that's built in as well. And the third one you see there with the little loop-de-loop arrows thing, that's the refresh token, which is optionally returned. And essentially, in the case where you get one, and if you know you need one, you would get one, it allows you to, in an offline mode, if any of the access tokens have expired, to request a new one without user intervention, which means that you can keep your access token expiry as small as possible, which means that if an access token ever gets leaked, then the effective time that somebody could abuse that token is reduced. And then the refresh token allows an authorized application to get a new token once that access token expires. All right, let's move on to the one that we don't use anymore, the one that shall not be talked about, but we will because it's useful to learn how we've learned about things. And this one's called implicit flow. Implicit flow was designed to solve the problem of single-page applications because there is no back-end server, so we can't store a secret key because you can't put a secret key into browser code because otherwise it's no longer secret. So the idea here was that we would make a request and we would send just the scopes and the client ID. And in return, the identity provider would do that login thing. You can see the slightly transparent little loopy thing there. We'll assume that they've logged in already, so they're not going to be prompted to log in again. And in return, it's going to respond to that that request with a response that contains information in the hash part of the URL. So in a URL, you've got like the domain, you've got the path, then you've got the query string, and then after the hash sign or the pound sign, depending on which part of the world you come from, you can have other information, sometimes also known as an anchor to get you to a certain area in the page. You can also use that for transmitting information between systems. Traditionally, the access token and the ID token would have been returned as part of that hash. Now, some of you in the room will probably be looking at this already saying, well, I know why that's a problem, because hashes are part of the URL, therefore they go into your browser history. They can also be bookmarked, and they also appear in logs and various other things. So that's obviously not ideal. At the very worst end of the scale, it means that somebody could potentially intercept that somehow and get those tokens out within a small time frame, obviously. But even at the inconvenience side of it, if I've opened something up on Firefox on my mobile phone and I've got it synchronized with Firefox on my desktop, and I start typing a URL of the page that I just went to and it auto-completes with the token in the hash, then that's just going to confuse things because that token is no longer valid, or the hash breaks in some way the understanding of whether or not the user's logged in. So it's not ideal to return that in this way. So that's why implicit flow was deprecated. But in the same way as with the other systems, you could use that access token to then talk to APIs from your single-page app. So it was a good way of solving, in the first instance, the problem of how to authenticate people to single-page applications and allow that application to then talk to APIs in order to pull out all the data and information required to get the content into the page that was relevant to the person who just logged in. So the solution to this is Authcode flow, which is the first one we saw, plus PKCE. I like PKCE. I always imagine something with ears and short hair. It's pronounced PKCE probably because it's a cute name, but it stands for Proof Key for Certificate for Code Exchange. So code, yes, because it's for the Authcode. So the proof key is basically another randomly generated, cryptographically, securely randomly generated blob of information. And what happens is when the single-page application makes a request to the identity provider in the first place to authorize, we've got the client ID and the scopes in there, but we add in a hashed version of that proof key. So as the single-page application, if I can, the opposite of personify, like when I turn myself into an inanimate object, I can't remember that word right now, but if I do that to myself and I pretend that I'm a web application running in the browser, I'm basically going to generate a really secure random bit of information, then I'm going to hash it, and I'm going to send that hash with the first request. And as we probably all know, reversing a hash is really hard, and that's the idea. So the identity provider now has a hash of some information, and it doesn't know what that information is, and all the information required to allow that login to happen. So as a response to that now, it's going to return that auth code. So we're looking at the auth code flow again that we saw in the first step, but now we need the web application, which is running purely in the browser, to make a request to Auth0 to exchange that for tokens. In the first example, we had a secret key, but as I've mentioned, we can't put a secret key into a single-page app, because otherwise it's no longer secret. So what happens instead is it makes that post request and it says, hey, here's the auth code you gave me, and here's the original version of the proof key, the unhashed version. So now Auth0 can say, well, the first time you sent me the hashed version, the second time I know how you hashed that, so I can hash the unhashed version, and if they match, then I know that the request for the tokens came from the same browser, or the same even tab, the same running application, as the original request for login happened. Does that make sense? I'm getting nods. I don't see any shaking of heads, but please do raise your hands if you want me to go into explain any details of this. So in response to that, because it's like a fetch request in the background type thing, but it's a post request, we get then a response in the payload, which means that none of those tokens that in the implicit flow that were in the actual URL, the hash part of the URL, none of that information is in the URL anymore. It's now a response from a post request. And then, of course, you've got an access token that you can talk to your API with. The next one's really easy. The next one is machine-to-machine. Client credentials flow. This is basically where you provide your client credentials in exchange for a token. And it's so easy, I'm just going to expose both of the arrows, because essentially, because it's server-to-server, you can use an identity provider to say, hey, here's my client ID and my client secret, and I just want an authorization, an access token. So there's no identity in here. There's no human involved in the login process. It's purely for system-to-system communication. But it means that you can include in your configuration of all your identity provider kind of configuration where you've got your clients, which would be your web applications, you've got your APIs configured. If two APIs need to talk to each other, you can configure within the identity provider the fact that an access token can be consumed by the other API. So in this case, one system is saying, hey, I want a token to talk to that system over there. You could do that in a very simple API key-esque, like the other system just needs some kind of password to authenticate. But if you've already got identity provider providing access tokens in all the other parts of your ecosystem, then it makes sense to keep it all in one place. And now you've got access tokens that can be used directly between machines in your ecosystem for secure communication and authorization components of that. So now the third-party system that just received the token in response can talk to the API, not as a user in this case. The authorization would basically be a system authorization or a service authorization that doesn't contain an identity token component. And the fifth one is probably my favorite, device flow. It's my favorite because I managed to get a designer to create me an icon of a fridge. Does anybody have an internet-enabled fridge? Does anybody have an internet-enabled anything that you never would have thought 5 years ago would have been internet-enabled? One. Okay. That's one more than I've got some more people admitting to it now. I feel like maybe you're keeping it a secret, and I'm not sure why. I'll come and talk to you later. So device flow, this is basically a scenario where you have what we call input-constrained devices. It's a device where there's no keyboard. Now, often you'll find a touchscreen onboard keyboard, which can be somewhat okay to use. On the other hand, you might get into the situation where you're logging into your favorite streaming provider on the TV, and in order to type in your password, you're going right, down, enter, back, and oh no, wrong one, over, down, delete. And about 4 minutes later, you realize that you made a typo somewhere and you've got to start over. There's got to be an easier way, and that's what device flow does. So, device flow, the fridge boots up. I never thought 10 years ago that I would say the fridge boots up, but the fridge boots up. And it says, look, I'm using Auth0 as my identity provider, and I need somebody to log in so that I can, I don't know, store the shopping list somewhere for them, because that's what internet-enabled fridges do, right? So I need some kind, here's my client ID. I need some kind of token to be able to talk to this external system. And what the identity provider is going to do is return, because a device flow authorization process was requested, it's going to return some information that the fridge or whatever device is trying to get some kind of information about the user, the fridge can use in order to help the user provide more information about their identity. And that information traditionally will include a device code. This is a unique code for this device now. A user code. So if you've ever done one of these on-screen logins where it says, make sure this code is correct, or type in this 8-character code, that's the user code. That's the code that the user needs to provide to become part of this loop of authentication. Verification URI, that's where the user needs to go. That's the URL they need to go to in order to complete the login process on some other device. That's why it's called device flow, because we use another device for the authentication component. So the verification URI complete. I don't know if this is in the standard. It's certainly something that Auth0 returns, and basically it's a convenience thing. It's the verification URI plus the user code. So from your perspective as a developer consuming this information that's coming back, you can just take the verification URI complete, present that to the user somehow, and that's where they need to go in order to be able to log in. We've got expires in. Again, I don't know if this is a standard, but the default with Auth0 is 15 minutes, so you've got 15 minutes to complete this process. And we have an interval, and this is the interval at which the fridge needs to keep checking, because there's no push notification type mechanism here to get the information back to the fridge. The fridge is going to have to poll the identity provider saying, hey, do you have any information yet? Because the authorization, the authentication process is happening from a different device. The fridge is unaware of when that happens. So it's going to poll at this interval, which for us defaults to 5 seconds. So the next point here, part 3, is this polling mechanism. So as soon as it receives that information, the fridge is going to say, hey, got a token. The identity provider is going to say, you only just asked me for this request. Do you think the users are that fast? Probably not. And then 5 seconds later, it'll say, hey, and the identity provider will say, slow down. Actually, it doesn't. There's no protocol saying slow down. Actually, no, I think I tell a lie. I think because I wrote a mechanism for opening an IoT door using device flow, and I think I got to the problem where Python was running slightly fast, so it actually tried to do a refresh after 4.98 seconds or something, and Auth0 actually said, what's the HTTP error code for slowdown? 4 something. I agree with 4. I'm glad that none of us know. I think I heard 409. I'm not sure if that's true, but I think that's what I heard. So that happens. Meanwhile, the fridge is going to somehow communicate to the user, here's how you're going to be able to log in. And this could be a QR code. It could be a really long string that the user's got to type out and they're going to hate you for. It could be via NFC. Maybe there's an NFC device on the fridge itself. You hold your phone up to it and goes, here you go, here's the login page. Whatever mechanism it is, it's a non-contact kind of communication. The fridge is not communicating with your phone directly. It'll just present this information in some way to allow the user to start the login process. And from that point, the user is going to get the user code or the URI complete in order to load the login page. And once they run to the login page, you can see here I've got the little gray arrow, so let's assume that they're still logged in, which is nice. Auth0 is going to know who they are already, but they're going to get that confirmation. Like, this is the user code that you were given. Just hit confirm to say that you want to log into the fridge. And as soon as that happens, as soon as the user's logged in, the next request from the fridge, when the fridge goes, hey, you got a token from me yet? At this point, the fridge is getting quite despondent. It's not very happy with the situation that keeps being rejected. But finally, hopefully within 15 minutes, the response comes back and say, hey, here's an access token. So one thing I really like about this is if you look at the mobile phone and how many connections it has, there's just one. I mean, there's obviously going to be a response, but whatever that response is it's totally irrelevant to the auth flow process here. But the device is totally separate to the whole communication flow of getting the token to the fridge. And that makes it really easy for people to log into input-constrained devices, IoT devices, things like that. And now the fridge has an access token that can talk to the API with. Cool. Those are the 5 flows that I want to talk to you about. Next thing I'm going to do, and if anybody has any questions at this point about these, you're more than welcome to stick your hand up, or if there's anything from home, nothing. I can take the questions at the end as well, yep. But there's no questions about this one, because I'm going to move on to a different talk.
I have 2 questions here.
Shoot.
Hello.
Can we get the handheld mic on? Thanks.
Hello. So the first question I have is from Ian. The question is, how device biometrics work on Auth0?
Biometrics? Yeah. You will use WebAuthn, which I will talk about next. Cool, that was nice. Sorry, I should talk to you at home. You will use WebAuthn, which I will talk about next.
And the next question is from Sean, and the question is, how can we automate tests for a backing API that normally expects a user's access token on behalf of?
Sure.
My initial thought is to use the client credentials flow for the unattended test automation framework, Postman, for example, but then it wouldn't be attached to a user's identity.
This is true. So I don't think that I have time in this session to go in depth in an answer in that. But what I tend to do when I'm doing testing like that is to mock the tokens themselves. And in order to make my life a little bit easier, and you need to be careful that this never leaks out into your production environment, use environment flags to your, or don't use them to your detriment. You can actually sign JSON Web Tokens with the none algorithm, which means you can basically just generate a header and a payload, no signature at all. You need the dot. So in terms of how JSON Web Tokens look, you've got the 2 base64 URL encoded components, the 2 full stops, and then the rest is blank. That's the standard for a none-signed token. And then your web application, or your backend API can basically just trust the fact that the none header and the lack of a signature means that it's valid. So it makes your tests a lot easier to do rather than having to generate and sign JSON Web Tokens for everything. But there is a risk there that if you accidentally get that into production and production suddenly supports none-signed JSON Web Tokens, you're opening yourself for a world of hate and pain. So just be very careful about that. But I'm sure there are other ways of doing it as well, but that's just the way that I do it. Thank you. All right, so let's jump over to this one. Now, unfortunately, because I can't quite maximize my screen completely, you'll see a little bit of leakage of slide components on the left and right here. But with 20 minutes left, I'm going to really skip through quite quickly of the intro of this part, which is basically describing WebAuthn and where it came from, because I want to jump straight into the actual flows, because that's what we're here to look at, the actual auth flows. So that's a bit about me. So the thing when you're looking at passwords is that when you're trying to judge whether or not a password is good, is it easy to remember or hard to guess or clone? Is it easy to change, and is it hard to intercept? So I created this graph here, which I'm going to skip through very quickly so I can just talk about them and bring in, is that the last one? There we go. So let's have a quick look at this one. We've got traditional passwords on the left there. They're really easy to change because they're just something in a database. They're hard to intercept. I'll put that slightly lower down because they can be intercepted. It's a bit of a middle risk range, but they are really hard to remember. Password managers are obviously your friend. But that's one of the issues we have with passwords and why people reuse them is because they're hard to remember. If you look in the middle, where we start looking at passwordless stuff, that makes life a lot easier. They're harder to change sometimes because, especially so on the voice side of things, it's harder to change because the learning process of the voice is a bit trickier, the way that's stored. But if you look at something like SMS, they're slightly easier to change, not quite as easy as passwords, because even though it's still just updating something in the database, if you change your SMS number, for example, there's got to be some kind of verification. You've got to send an SMS and make sure that code is returned and kind of close the loop on making sure that the new mobile number that they've provided is actually one that they can receive messages for. But the one that I want to focus on is the stuff on the right-hand side. So we've got client certificates, which I don't see a lot in the wild, probably more in the enterprise kind of worlds where you have a certificate that you install into your browser, and it's a client certificate, so when you make a request to a web server, that certificate gets included, and it provides a phishing-resistant mechanism for authenticating yourself to the web application. But arguably much easier than that nowadays is a FIDO security key. Aaron mentioned a bit about WebAuthn in his talk earlier today. You can use things like YubiKeys, the fingerprint reader in your MacBook Pro, the fingerprint readers on your phones. A lot of these, I'm not going to say all because I'm sure there's going to be at least one out there that somebody will catch me out on. But a lot of these allow your device to create a credential or to complete a credential process based on this FIDO standard, which is phishing resistant. And the reason why I want to go into the flow of how WebAuthn works is to describe exactly why it protects us and makes it really hard to phish for credentials. So let's have a look at an example of how a phishing attempt would work in the first place so that we know how, or we can see how WebAuthn is protecting us. So we've probably all been in the situation, I know I have, and embarrassingly I've actually submitted information to forms that I really shouldn't have, including credit card details. Honestly, I don't think anybody's actually on camera, but just show of hands, how many people have actually filled out a phishing form and then afterwards thought, shit, I shouldn't have done that? Okay, I see 4 hands, so like 25 of you are lying. It's happened to all of us, and it'll happen to all of us again. You go to g00g1e.com, and it looks like Google. Maybe you received an email saying you're out of storage, you need to upgrade your Google One account for more whatchamacallit. There's a link, you click on it, and it looks like a Google login page. Okay, cool. This is what I was expecting. I'm going to put my username and password in. The next thing that happens, the credentials are passed in. The next thing that happens is whoever's attacking you is going to send you to a fake success page. They could even, because the likelihood is if you're a Google user to the extent that you expect to have to upgrade your Google One account, then you're probably logged into Google already. So if they redirected you to photos.google.com, then Google would say, oh, this person's logged in already. So it actually feels like you can see your photos. So it feels like you've actually logged in. Meanwhile, your credentials are being sent to this fake website. But there's a reason why the attacker might want to send you to a fake success page. Because meanwhile, it's taken those credentials and it's passed it to some bad actor, probably a script. And that script is going to make a request to the actual Google servers with your actual credentials and say, I want to log in. Now, at this point, two-factor authentication is going to save the day. Because you're going to get an SMS with a code, or your phone's going to pop up with somebody's trying to log in, and you hit yes, because that's exactly what you're trying to do, and that's exactly what you're expecting. So meanwhile, you've just authenticated the attacker's login. But if it's an authentication code that came via SMS, the attacker's going to need to get that from you somehow. So this fake success page could ask for that code. So that's why it's a good idea. I'm not recommending you do this, but that's why it's a good idea if you do, but don't, to have a fake success page so you can collect more information from the user you're trying to attack. Finally, the attacker gets the actual Google account and can do whatever they want because they're logged in as you. So essentially, phishing relies on fake login pages. That's what it boils down to at the end of the day. So how can we remove fake login pages completely? So web auth and registration login flow. This is the fun part. There are lots of components here, but keep an eye on the flow of what's actually happening between the user and a system. Because while there's a lot of data movement here, hopefully you'll see the actual user experience is quite simple. So I'm connecting to some web application. You've got a website that you've just set up, and I've said, look, I want to log in. And with WebAuthn, you actually provide your username as part of the request to log in most cases. So I'm going to say, hey, my username is Ben, and I want to log in. I want to create an account. And your web application is going to say, OK, cool. I don't know anything about you, so I'm going to send you a challenge. And again, this is similar to the PKCE workflow, Authcode flow, in that there's some kind of cryptographically randomly generated code that gets sent to the browser, back to the browser, because the browser plays a huge part in this communication process. So this challenge gets sent in, and meanwhile, you've got a YubiKey or you've got a touch thing on your laptop or fingerprint reader on your phone or whatever it is, whatever FIDO-compliant device you're using. There's going to be a request from the browser to an internal API built into most of the modern browsers called, it was actually visible there, navigator.credentials.create. The navigator being like the web navigator, the browser, credentials being the credentials API, and we want to create a new set of credentials because this person has never logged in before. And into that request, the browser is going to pass in the web origin, so where you're logging in from. In this case, it's going to be yoursite.com. And this is where the fake login page thing comes in, because if I'm logging into google.com, this is going to say google.com. If I'm logging into g00g1e.com, or whatever I had, then this is going to read that. So essentially, you'll be creating two different sets of credentials for those two different web origins. The browser knows exactly where it is, so it is able to specify exactly where, it's able to specify the key, the web origin that's going to be stored in the database of credentials, so that it's unique to that one website. Does that make sense? If you go to a different website, you can never use those same credentials. You can never load those credentials out because the navigator.credentials API is not going to allow you to get that if you're at the wrong domain. Humans are very, like our meat brains are very trickable. We look at a malformed domain and we don't see it. Computers don't make that mistake. So navigator.credentials.create gets called, and it's going to generate a public-private key pair. It's going to store the private key within itself, so within the Navigator Credentials API. It stores that information. So if you've got a YubiKey, it could be storing that on the YubiKey. Otherwise, it might be storing it inside your whatever FIDO-compliant presence-proving mechanism you have. And it doesn't have to be biometrics. It can be non-biometric confirmation there as well. Some YubiKeys, for example, are just presence detection. They don't need a fingerprint, but a lot of them do also require fingerprints as well. And it's going to return the public key and the generated, the signed challenge. So the challenge that came through originally from your web application, it's going to get signed by the private key, and it's going to return the public key and the signed version of the challenge back to your web application. That's that part there. And then your web application is going to take that information and pass it back to your backend application. So it provides the public key and the signed challenge. Your web application can now store that information in this database. So remember when I made that first request, number one, I provided my username. So we've got a username already. We're now going to store the public key, and we're going to verify that the returned signed challenge is equivalent to the original challenge that was sent out, and that it's signed with the public key that was returned. Now, you might be thinking that there could be a point in that process where somebody could modify the public key and re-sign the challenge to try and make it work for something else. But remember that only happens once at the first point when you're creating your account. They would have to somehow be able to fake the web origin, which is going to be nigh on impossible. I'm going to say non-zero likelihood of it happening, but nigh on impossible. So the likelihood of there being a hole at this point is so fractionally tiny, it might as well be non-existent. The next time somebody logs in, they say, OK, my name's Ben Dechrai, I want to log in. And this time, the server says, OK, well, we know your username. And we've already got a public key against your username in the system. So now we're going to do a login process. So here's the challenge again, but here's also the identity that we know about you. So there'll be a UID, or a unique ID generated for that user within the public-private key pair. And basically, your application is going to say to the web browser in response, hey, somebody's logged in before. Here's the UID they had when they created the account. Here's a challenge that I want you to sign. Go do it. So, and I mentioned at the beginning, thinking about the user experience flow at this point. Basically, the first time I logged in, I provided a username, and then I touched my MacBook Pro, or whatever mechanism. That was the login process. And now I'm about to go, that was the account creation process, rather. Now I'm about to do a login process. I'm going to provide my username, and in a second, I'm just going to touch my MacBook Pro again, and that's the login process. So from a user experience perspective, it's really seamless. So the browser has just received this request saying, hey, I want you to now do a login process for this user based on this UID, and I want you to sign this challenge. So navigator.credentials.get is invoked, and into that we provide all the information that we received, plus also that web origin. So now, whatever device you're using for WebAuth, and whether it's your YubiKey or your phone or whatever, it's going to say, here's the web origin, so pull out the public-private key pair that you have for this web origin. Again, that gets rid of the phishing attack. Here's the UID, so make sure the keys you pull out are for this UID, because technically it's possible for like 3 people to be using the same laptop and want to have their own accounts. So that's why the user ID comes in useful at that point. So here's the user that's actually trying to log in. And here's a challenge that I want you to sign. So the FIDO security key is going to basically pull out the private key that it has stored for this user, for this web origin. It's going to take the challenge that it just received, and it's going to sign it again. And then the data transfer, the process back to the server is very, very identical. I don't know if that's good English. Very similar to the way the login worked. We're basically going to take that information, the signed key. We don't need to provide the public key anymore, because that's already in the browser, and we shouldn't provide a new public key, because this should be signed with the same public key, or the private key that we have the public key for already as the first time. Otherwise, what's the point in having public-private key, right? So we're going to make sure that your web application has the public key from the first time the person created an account, and we're going to use that to verify the challenge that comes through now. So the browser is going to pass that back to the server, and at this point, the server is going to say, OK, we know that Ben was trying to log in. We know that we then sent that UID, Ben's UID, back to the browser to say, hey, we want a login process. We sent a challenge, which needed to be signed, and somehow, we don't care how, but somehow that challenge got signed, and I can now verify that the response that I've received, the signed challenge, has been signed with a private key that is corresponding to the public key that I've got in my database. And now Ben's logged in. So it's hugely messy. Like from a process, from a flow, you can see like it explodes your mind to try and like see what's going on under the hood here. And I hope I've taken it step by step enough. And we do still have about 5 minutes for questions if you want to go into this one, or any of the other stuff we've talked about. But from a user experience perspective, it's like flawless. I love being able to log in by just typing my email address, and I just rest my finger on the keypad thing until suddenly I'm logged in, and then it's done. So I love that. So that's how WebAuth works. That's how it keeps you secure from phishing attacks. And I hope that made sense. Any questions? Does that mean you need to set it up with every device that you have? So you do need to register every FIDO security key that you want to be able to log in with. So this is a really interesting question. Like, what happens if you forget your password, where your password is a YubiKey or a laptop? So you would probably want to have backup login mechanisms. So if anybody in this room has access to systems that they can only log into with a security key, and you don't have a second security key of some sort, get a second security key of some sort. It's a good backup. Depending on the back-end process as well, it's possible to reset this. If you're treating this as a multi-factor authentication process, then you can disable that and re-enable it and re-register the person. You've got another way of verifying who the user is. You get similar issues to any kind of password reset mechanism. You need to be able to trust that you know exactly who the user is to be able to reset that. If you work in a corporate environment where you have to use your key to authenticate, then you would have to get in touch with the support people and somehow verify, and they would do a reset process for you. But much easier would be to have a second device that allows you to authenticate as well, that you can then log in with, invalidate the old one, register another one, that kind of thing. Yeah, but that's a good question. And hopefully that was a sufficient answer. Any other questions? Anything from home?
One more.
One question.
From Ian, how about multi-device?
Multi-device. So wanting to log into the same, I'm going to assume this is about wanting to log into the same application from more than one device, and that's probably a similar question to, and maybe that's the question you were asking, and I went down the backup a bit too much. But yes, if you want to log in from multiple devices, then you are going to have to find a way to authorize yourself to the device for the first time. There are different ways that you can do this. If you're writing the application, like, for example, if I log into, I think it's Amazon Prime or one of those, once I've logged in on my mobile phone, I can actually, when I log in on my TV, I can put in my email address, and my phone will say, somebody's trying to log in from name of TV, and I can hit yes. So you can do it that way as well. And at that point, you're logged into the system. So you could then also register that as or the FIDO security key on that system. So to put that into a more tangible example, if I've logged onto something with my phone and I've used the touch sensor on my phone to enable FIDO-based security, and then I want to log in from my laptop as well, then when I log into the laptop, I could, for example, show a QR code on the laptop that I scan with my phone that then completes the authorization process. And then I can go into my account settings in the application on my laptop to register a new key, which could be my laptop itself. So there are definitely ways of doing it. The other thing you can do is if you've got a removable or a portable key, like a YubiKey, is you can plug that into any device and use that for the login process. Because all the information, the web origin and the keys, the public-private key pair, are stored on the device itself. Cool. Nice question. Nothing else at home? Anybody else? No? Oh, one over there.
How about the vice versa? Multiple accounts? Can we do multiple accounts using one FIDO device?
So multiple accounts with one FIDO device. So I touched on this vaguely with the UID that comes from the application. You can actually have multiple users on one device for one web origin. And in fact, if you've ever been in that situation and you have a MacBook Pro, and in fact, probably any application that does this, wake up. There is actually built into the browser a prompt that comes up if there are multiple identities stored against one web origin saying who you're trying to log in as. And I won't go into this in too much depth, but this actually allows a form of usernameless authentication. So you need to provide a username when you first create your account, but you can actually request a WebAuthn login flow without providing a username and allow the username to be specified by the key that's selected by the user who then authenticates, if that makes sense. It's a little bit convoluted, but imagine you've got Alice and Bob, because in crypto world, we love Alice and Bob. Alice and Bob both have an account at google.com. They go to google.com and say, I want to log in. I'm not going to tell you anything about me. Google responds saying, I want you to start a WebAuthn. And I'm picking on Google here a lot. I have no affiliation, love, or dislike for it. It's just like the domain that we all think of by default. I should call it example.com. Logging into example.com. And it says to the web browser, we want to start a WebAuthn flow. The WebAuthn, the Navigator Credentials API is going to say, well, I've got 2 users for this. Which one do you want to use? Shows you a user interface, and Bob will say, well, I'm Bob, and then can use their fingerprint to authenticate. So you can definitely do multi-user in that way. We have 41 seconds left, and I saw a hand raised over here. No? OK. In which case, I think this has been timed perfectly. I'm going to be the Auth0 stall if you have any more questions about this. Aaron's going to be there as well to talk about the Okta side of things and OpenID Connect and all of those things. I did say that I wasn't going to mention it again, but I will mention it again. Please go and build some Lego and enjoy the rest of the conference. Thank you so much.